So what we're going to have here is a little review of the idea of composite functions. So composite functions are a layering of an inside and an outside function. So for example, this m of x equals 2x plus 3 all raised to the fourth power. What we have are kind of two pieces here. We have at the inside of everything, this 2x plus 3, and at the outside of everything, this raising to the power of 4. So what we could do is to write this as these kind of separated functions. What we could do is describe it as a function of having something raised to the fourth power, and then a second function of this 2x plus 3, where this 2x plus 3 is being input for x there. So what that would look like is having m of x is equal to, and I actually want to change this a little bit. I don't like that O there. It should look a bit smaller, kind of like an open circle like that. For f of g of x is how I would read that out loud. F of g of x, where g of x is the inside function and f is the outside function. And we could layer it like this, where we see g of x on the inside and f of x on the outside. So part of what we need to do here is we need to be comfortable with identifying what's the inside function and what's the outside function, because that's how we'll apply this chain rule for taking the derivative when we have a layered function like this. So just to kind of go through the steps there of if we have f of x is equal to x to the fourth and g of x is equal to 2x plus 3, and I wanted to find f of g of x, it'd be like my f of x is telling me, okay, raise something to the fourth power. What are we plugging in? We're plugging in the 2x plus 3. We could also go in the other direction, like I could go g of f of x, and what we would do there is g of x is telling me, okay, take 2 times something plus 3, and our input is f of x, which is equal to x to the fourth. So that would be the same as 2x to the fourth plus 3. So what we're going to need to be in the habit of doing is identifying inside and outside function for applying this chain rule. So if we want to take the derivative of a composite function, f of g of x, or if we think of it as this layered form where g of x is the inside function and f of x is the outside function, then what we're going to do is take the derivative of the outside function, keeping the inside function the same, times the derivative of the inside function. So this is the notation for it, but that's how I read it out loud to myself, and I even wrote it out in words down below, because I find that kind of saying that out loud in words is helpful for using the chain rule. Sometimes this notation can be tricky to follow, but derivative of outside, keeping the inside, and then multiply with the derivative of the outside. Just don't forget that piece. This is a common piece to leave off. We always want to multiply by the derivative of the inside. Which, let me make sure, sorry, I'm reading this quickly. We take the derivative of the outside function and keep the inside function, then multiply with the derivative of, that is a major typo right there. It should be the derivative of the inside function. Okay, there we go. So, derivative of the inside function. So let's try this out. So again, I'm thinking of 2x plus 3 as the inside function, exponent of 4 as the outside function. So we have outside, inside. So if I want to take the derivative of m of x, what we're going to do is think of how do we take the derivative of something raised to the fourth power. So if I have something raised to the fourth power, so this is the derivative of my outside function, we would bring 4 out front, bump the exponent down by 1. So there's the derivative of my outside function, and we keep the inside function. So this right here, I'm going to write this out in words. Derivative of outside keep inside. We keep the inside function the same. And then we're going to multiply with, and what we're going to have here is derivative of the inside function. So 2x plus 3, the derivative is going to leave us with a 2. So this right here is the derivative of the inside function. And then we'd simplify, which in this case would be 8 times, and then we could just leave this as 2x plus 3 cubed, just like that. So I'm going to keep talking about this way of having the outside function and inside function, and we'll just take this derivative of outside, keeping the inside, and then derivative of the inside. Okay, let's try this out here. So identifying the inside function, what I also do is I tend to start there with thinking about if I plugged in a number for x, what are the first things I would do to it rather. Here I would cube it, multiply by 4, take away 9, and then I would take the square root. So I could think of this in 2 stages where I would have all these calculations around x, and I could finish everything with this square root. And in fact, I'm even going to rewrite this as 4x cubed minus 9, and then having this exponent of 1/2, so that you can really see this exponent on the outside of everything, and our function that's inside is the 4x cubed minus 9. So taking the derivative here, all I'm doing here is thinking about how do I take the derivative of something to the 1/2 power. And I don't even really care what's inside there. So what we would do is bring the 1/2 out front. We'd have our function, and then raise it to the 1/2 minus 1, which is a negative 1/2. And then, so this is the derivative of the outside function, and we keep the inside function the same. And then we need to multiply with the derivative of the inside, which I'm just focusing on that 4x cubed minus 9 here, and taking the derivative, which would be a 12x squared. And then we simplify. So I'm going to have 12x squared in the numerator over 2 times, and we could leave this as 4x cubed minus 9 to the positive 1/2. And then I have a 12 divided by 2, so I'm just going to simplify that to a 6x squared over, and we could even change that to a radical if we wanted to, a 4x cubed minus 9. And yeah, we'd leave it just like that after simplifying. All right, let's do another example here, and then I'll break up the video so you can try these out on your own. So with this one, at the outside, I see that exponent of 20. Inside, I see this 4x cubed plus 15x squared. So taking the derivative, thinking of derivative of the outside function, keeping the inside function. So derivative of that exponent of 20, bring the 20 down. 20 minus 1 gives an exponent of 19, and we keep that inside function the same. And then multiply with the derivative of the inside function, so that 4x cubed plus 15x squared. So 4 times 3 is 12, x to the 3 minus 1, plus 15 times 2, x to the 2 minus 1. And yeah, not much to do in terms of simplifying there. We could take out common factors from that, but let's go ahead and leave it just like that there. We could rearrange it, but it won't change very much. So we'll leave it just like that for this one. So that's the beginning of our chain rule, and then I'll go through a few more examples and scenarios in the next video.